Recently, we've had an influx of these smaller reasoning models. I just wanted to see if we can actually use these to, you know, to do something reasonable with them. So I've been mainly checking out these two models. First of all, 5.4 mini reasoning from Microsoft, as well as the Qwen3 models that dropped like 3 days back. Even the 5.4, basically, if you look at Olama's, if you go to Olama, it basically dropped 5 days back. Um, so specifically the model that I was trying out was this 3.8 billion parameter. I believe this is the 4-bit quantization model. Yes, that's what I tried out actually, because I'm actually running everything on CPU, since I don't have access to you know a more powerful computer with GPUs. I've actually run not this particular model, but the Qwen3 0.6 billion model. We'll come to that later. I've actually tried that out on my Raspberry Pi 5 as well, and then it's pretty decent. The performance, I mean the number of tokens per second, it's pretty decent. Um, so this particular model, the 5.4 mini reasoning model, this is a little slower compared to, of course, it's 3.2 billion, sorry, 3.8 billion parameters, so it would be a little slower. But the main problem with this is the actual reasoning, the actual thinking is a bit too much, I guess. I guess in true Microsoft fashion, it's just it's overcomplicating things. In contrast, um, the Qwen3 model, especially the 0.6 billion parameter model, which is quite a bit smaller, um, I've been pretty impressed with this actually. Um, it doesn't take that long to reason, and then it runs quite fast on my laptop as well. I mean, my laptop is quite a little, it's quite old. This is the older generation Macs, the Intel Macs, one of the Intel MacBook Pros. I think, believe it was 2019 or something. So it's a 8-core CPU, so it runs okay on my laptop. But I guess if you have a more powerful system, and then if you have a GPU with a bit of VRAM, I would assume it would run much faster. But the main reason I wanted to okay, so there's a small script that I've been using to test out these models. Um, yeah, like I said, the main reason I've been trying out these models is because I actually wanted to see if it's possible to use this for these smaller models for agents. Um, And to be honest, I've been, quite successful. Let's get into an example. Let's run the script. Um, so I'm actually using Redis for short-term memory, because I mean we are not using any kind of kind of an agentic framework. It's just this simple script that we've written. I wouldn't say it's simple. There's like so many functions that written that can be used as tools. Yeah, so let's get into it. Let me just do a simple high first. Right now we have, I mean, quite a comprehensive system prompt here. Since we are using tools, it would take a bit of time to initialize that system prompt. That's why it's taking a while for it to respond. But like, if you can, if you just saw once it gets going, the tokens are generated quite fast. Um, yeah, it's okay. Um, so in terms of functionality, so we've added web search using DuckDuckGo, and then we have beautiful soup um, integrated as well, so that it can actually access the web links that we search for. And we've written a simple function that lets the agent write Python code and execute the code itself. Um, but this like I mean I've implemented some sort of let's see sandbox. I wouldn't, it's not really sandboxing. We basically I've added some safety measures in terms of what it can actually do, and it has the capability to run. Where is that? Where are the commands? Uh, where is this? Okay, so we have a. So I have given it access to the terminal as well, but I've limited it to a set of functions then that it can actually run because uh, since we're just still testing this, it's not a good idea for you to give it complete access to your terminal. So yeah, let's try something out. Um, so we're going to try something a little complicated. Um, so today we had the meeting between Mark Carney and President Trump. So let's see if it would be if it would be possible for it to summarize the news. Mm, check what if I can type properly. Carney and Trump today and give me a summary. All right. Yeah. So it's doing the reasoning. So yeah. All right. Let's see if it will actually use the web search tool. Okay. Mm, all right. So what did it do? All right. All right. So okay. So I believe it searched for some news or search for recent AI developments. I don't know why it did that, but yeah. Okay. So if you say I'll summarize the meeting between Kanye and public information. The meeting between Kanye and Trump was public and discussed policy, recent priorities, and public opinion. Kanye was so key initiatives while Trump. Mm, no, I don't think this is it. User, I mean, to make sure. Okay, no. Search for news on Trump meeting Connie and give me a summary. Alright, let's see if it will actually use the tools this time. Alright, so sure. Okay. Okay, so now it's actually using the, yeah, it did the web search. Yep, okay. Key takeaways from Donald Trump's meeting, South one. Yes, from Donald Trump's meeting with Connie Green. Okay, okay, alright. That's good. Let's see what it will do now. Okay, because I've made it so that it'll go through a couple of iterations before it stops. Okay, it's doing a web search again. Let's see. Okay, so it's actually giving us the web search result. Uh, Meeting between Trump and Carney involved discussing policy priorities and public opinion. Carney. Alright, so this is actually going back to what it had probably in his training data, or it's just making things up. So that's actually, I guess, showing the inconsistency between these when it comes to these smaller models. Even though it has access to these tools, I guess the tools could use a bit of fine tuning as well. But Well, so let's do something else now. Right, and um, execute code to calculate the root of 50. All right, and execute. Okay, see if it will actually do it. All right, it's doing the thinking. Mm-hmm. Okay, so it's going to use the square root function from the math library. Let's see if it will actually do it. Mm-hmm. Okay. All right. Yep. So it basically wrote the simple Python script and then it executed the code, which is cool. All right. Let's give it another try. Let's. Okay. It's still doing the second iteration. Let's wait until it stops. Yep. It's okay. It's using up. I think my beat up is frozen. All right. All right. So it did the calculation. Yep. Okay. All right. So let's try something else. Let's see if we can actually list this in my desktop directory. So it's not smart enough to figure out that I'm on a Mac, so I'll have to specifically tell it that I'm on a Mac. So let's see if it will actually do it. I am on a Mac. Can you, if I can type, can you list the file on my, let's give it the relative path so that make it a little easier. Desktop or RY. It's taking a while again. I guess I'll have to do a bit of fine tuning. It shouldn't take this long, even though we are caching the prompts and the entire conversation in Redis, probably because the Redis instance is actually running on my Raspberry Pi 5, and then it's running off of the micro SD card instead of I haven't used a NVMe SSD, so that could be a reason that it's a little slower. Yeah, so it actually listed all the files on my desktop folder. My desktop is quite a mess right now, so that's why you see a lot of files. But yeah, it actually did it. So as you can see, it's quite capable, even though it's such a small model, just 523 megabytes. Even if you load it onto your RAM, it doesn't take up that much RAM. So it's quite impressive what we can do with such a smaller model. Um, I guess the more context you give it, the better it will be. So if we use something like the MCP protocol, the model context protocol, maybe it'll perform a lot better. So maybe that'll be the next thing that I try out. Just as a final try, let's see if we can actually ask it for the weather, right? Current weather in Toronto. What's the weather in Toronto? No, it already has access to my location. Let's see if we can weather in my location. Let's see if it will do it. It should ideally do the web search. I mean, it should call the web search tool. Mm, okay, it's taking a while. I'm pretty sure it's the Redis instance because even though it's Redis, it's actually uh, but it should be running on my memory. The Pi has 16 GBs of memory, so I'm not sure what's going on. Yeah, guess I'll have to do a bit of fine tuning. My beta is frozen. Let's cancel. Alright, it's actually doing it. Let's see what happens. Doing the reasoning. So if I was actually using the 5.4 reasoning model, it would basically do an entire page of reasoning. So it would take much longer comparatively to do the actual reasoning as well. I mean, on top of it being a slower model running on CPU because it's basically larger. Okay, so the current weather in Toronto, Ontario, Canada is very variable with temperatures ranging from 14 degrees to 21 Celsius. Sailing weather. Let's see if we can search the web for the weather in Toronto. See what it will do. I mean, it should ideally do the searching because we asked it to use this web search. If it doesn't, that would be a failure, I guess. Let's see. Come on. Come on. Why is it taking so long? Alright, finally started. To perform a web search, let me check the available tools. Okay. Alright, it's actually using the web search. Thank you. Web search results. Did it use the search results in the previous tool? No. Okay, let's see if this is actually accurate. Toronto weather, which is 11 degrees Celsius. I mean, it was off a little bit. Um, I mean, quite a bit, I guess. It's because, let's see what the temperature was. I'm not sure if it actually summarized the weather. It shouldn't have because it's using DuckDuckGo, so probably it's not getting the same result. Let's use DuckDuckGo. Okay. Weather in Toronto. Okay. So it's basically the same result, of course. Yes, of course it would be the same result. So I'm not sure if it's actually averaging out the weather or what it actually did because it would have probably used the DuckDuckGo API to fetch the results and then probably summarized the temperature for the entire day. Because when I checked today's highest temperature, it was supposed to go up to 21 degrees today. So maybe that's what it was doing. Anyway, so I guess that so I guess we can use this for running agents, but I guess it needs to improve a lot. Of course, if you used a bigger model, the results would be a lot more accurate, I guess. But the idea here being, if you're a company that would like to use agentic AI within your company, and then you didn't want to use any of the public APIs such as OpenAI or Gemini, and then you didn't want to expose your data to these larger language models, and then you wanted to keep all your data in-house, this would be the way to do it. So you would host your own large language models in-house, and then use your internal APIs to build agents. And if you have smaller models like these that can run on CPU, You wouldn't have to make a huge investment on expensive infrastructure to run these large models. So yeah, I'll be um, testing this out further, and then so my next plan is to try and use the MCP protocol, as well as see if we can use one of these agentic frameworks, maybe the LangChain and LangGraph libraries. So yeah, watch this space and I'll keep you updated.